if I think that gear, the influence of gear on the gas usage is different for different transmission types, then I think that the interaction is relevant and I want to include it. So if you want to include the interaction, you do LM again, but this time with this formula. So when I do this, there we go. And I want to see the ANOVA table again. So here we are, ANOVA. What happens if I ask for type 2? Then he ignores the interaction. And he's going to calculate the sums of squares using the type 2 approach. I get an ANOVA table. It's the same as the previous one because I'm ignoring the interaction. So I should get the same. Yeah? What happens if I do the type 3 here? I get an error. And that's normal. It's something that I do want to show. Yeah? The problem is that when you look at an interaction, you need to make sure that you have data for the interaction. And I'm going to show you why this is not the case here. So I'm going to load that package. And then I'm going to ask him to count, the number of cars for every group that is defined by the gear and the AM column. That's the two things, the two columns that I'm using at this moment as grouping variables. When I take a look here, you see why I get an error. Because this is okay, but I don't have cars with 5 gears and 0. They don't exist. And I don't have cars with 3 gears and 1. They don't exist. So if you don't have data for all combinations of your two grouping variables, then this interaction will fail. It will only work if you have data for all the combinations of groups. So I need to do something else here. Instead of gear, I'm going to use one of the other columns. I don't know what it represents, to be honest. But here, I do have cars in every combination of groups. So cars in 0, 0, 0, 1, 1, 0, and 1, 1. Cars everywhere. So this will work. Okay. So before I do anything, I have to factorize this column. And then I do LM again, but this time instead of gear, I use this VS column. And now when I do type 2, here we go, I get results for the main effects. I get result for the interaction, but here I repeat it again, this time with type 3. So you see that the interaction stays the same. So we do not have a significant interaction here. The p-value is higher than 0.05. So we can ignore this interaction. And we could go for this. For this result. However, if the interaction is significant, we would have to go for this ANOVA table. And you see that when the interaction is significant, you look at this p-value for VS. And you look at the p-value for VS here, you see it's different. And that is related to the fact on how he calculates these sums of squares. Okay. So, what do you report? The p-values here and the non-significant interaction.